Hello everyone, in this video I am going to teach you the different laws of exponent. Let's begin with the first one, product of powers. So here, if we're multiplying two exponential terms having the same base, we just need to add the exponent. So the bases here are x. If we have, let's say, x times x raised to 3, the exponent of x here is 1. So that's 1 plus 3, and this is equal to x raised to 4. Okay. Another example is, let's say we have x raised to negative 5 times x raised to 8. So here it's going to be negative 5 plus 8, and that is equal to x raised to 3. Okay. We can have two variables. So let's see, we have x times y, or xy times x raised to 3, and then y raised to 7. So this is x. The exponent of x here is 1. So add that to 3. It's going to be 4. Then y raised to, the exponent of y here is 1 plus 7. That's going to be 8. So that's the answer. Okay. There's a possibility that you're multiplying expressions, like they have the same base. We have x plus 1, let's see, raised to 3 times x plus 1 raised to 8. So this is going to be x plus 1. They have the same base, right? So raised to 11. Okay, so that's a possibility. Okay, let's go to the next one, quotient of powers. X cannot be equal to 0 here. So if we have x raised to 10 over x squared, that's going to be x raised to 10 minus 2, which is equal to x raised to 8. So we just need to subtract the exponents. Number 2, if we have negative integers or negative exponents, so let's see, negative 2 over x raised to negative 7. This is going to be x raised to negative 2 minus negative 7, and that is equal to x raised to negative 2 plus 7, which is equal to x raised to 5. Okay, negative 2 minus 7 is plus 7. Negative times negative is positive. And then another possibility is if we have more than one variable. Let's see, we have x raised to 4, and then y raised to 8 over x squared y raised to 7. This is going to be x. 4 minus 2 is 2. 8 minus 7 is 1. So x squared y is the answer. So it can also be like expressions like in my example earlier. Let's see, I have 2x minus 1 raised to 10 over, let's use a different variable, let's say 9. And then you got 2x minus 1 raised to 6. So it's going to be 2x minus 1. Do not forget the parenthesis 3. 9 minus 6 is 3. Okay, let's go to the next law of exponent, power of a power. So let's see, we have x squared raised to 3. So just multiply the exponents here. That's x raised to 6. Number 2, if it's negative, then you need to apply the the multiplication of integers. Oh, see, negative 5, right? So negative 4 times negative 5 is 20. Okay. One last example. Let's see, we have x raised to 2. No, let's try 6. And then negative 3 is going to be x raised to negative 18. 6 times negative 3. So for the meantime, we will keep the exponent negative because later on there is another law regarding a negative exponent. Okay. So what if there's more than one variable involved? We call that this is a power of a power. A variation of that is this one, power of a product. So let's see, if we have x squared y raised to 3 raised to 4. So just multiply the exponents. 4 times 2 is 8. 4 times 3 is 12. Okay, number 2, second example, let's have Okay, what if we have a numerical coefficient? Okay, this also applies here. Okay, I was not able to give you an example for that, but yeah, here, let's do that here. Let's say there's a 3 here, and then x, and then y raised to, let's see, 5, and then there's a square. So that's 3 square. I will write it here first. X square, and then y raised to 5 times 2. 3 square means 3 times 3, that's 9. X square, y raised to 10. Okay, 5 times 2 is equal to 10. Okay, number 3. Let's have number 3. Third example, let's see. We have um, 5 y raised to negative 2, and then y raised to positive, let's see, 6 raised to 3. Okay, so this is 5 raised to 3, x raised to negative 2 times 3, y raised to 6 times 3. 5 times 5 is 25 times 5 is 125. 125. Okay, and then x raised to negative 6, y raised to 18. Okay, next. This time we call this law as power of a quotient. Okay, so that means if we have, now y here cannot be equal to 0. Okay, this is a variation of this one, power of a product, power of a quotient. Okay, so if we have, let's say, x raised to 3 and then y square raised to, let's say, 5, this is going to be x raised to 15 over y raised to 10. Okay, let's have a numerical coefficient here. 2x raised to 4 over, let's see, 3y square. This time I will use a bracket. It doesn't matter. If you use a bracket or a parenthesis, raised to, let's see, 3. So 2 raised to 3, that's not 2 times 3, it's 2 raised to 3, which means 2 times 2 times 2, right? I will write it here first. So 3 raised to 3, y raised to 2 times 3. So this is 8. 2 times 2 is 4 times 2 is 8. X raised to 12 over 9. Oh, no, not 9. That's 27. Y raised to 6. That's going to be the answer. Okay. One last example. Let's see, we have negative, let's see, negative 4 over 5, and then x, y, 4. Okay, let me just look at the next one. Oh, yeah. It can have two variables here. So let's have, oh, no. Yeah, we can have two variables. So y raised to 4. That's this one, z raised to 2. There you go. Square. Now let's have 3. Okay. So this is negative 4 raised to 3, x raised to 3, y raised to 4 times 3 is 12 over 5 raised to 3, z raised to 6. Now let's evaluate the numerical coefficients. Negative 4 times negative 4 is 16 times negative 4 is negative 64. So x raised to 3, y raised to 12. And then the denominator would be 5 raised to 3 is 5 times 5. 25 times 5 is 125. Z raised to 6. And that's going to be the final answer. Okay, let's go to the next one. Here we have a negative exponent. Now, some teachers, they're very particular with this. They will tell you that the exponent should be positive. So if that's the case, then you have to use this negative exponent. We have 2 here. I don't know if you noticed that. Okay, so let's see if we have, let's apply the first one. We have x raised to negative 3. You want the exponent to be positive. That's going to be 1 over x raised to 3. Similarly, if we have, that's the first variation of this exponent. The second one is here on the right side. If we have 1 over x raised to negative 2, that is the same as x squared. So this will help you keep the exponent positive if it's negative, okay? Let me give you another example. So let's see we have a numerical coefficient, let's say 2 x raised to negative 4. So what will happen here is that 2 will stay there in the numerator, and that x raised to 4 will be in the denominator. Similarly, if we have, let's see, this time I'm going to put 4 here and then over, no, let's make it 5. 5 over x raised to negative, let's say 8. Okay, negative 8. So this will be, that 5 will stay there, and then x raised to 8. Okay. So what if we have two negative signs, like two negative exponents, like one in the numerator and one in the denominator? Yeah, I know that's interesting, right? So here, okay. So we have x raised to negative 3 over y raised to negative 2. So what we will do is that we will just switch their places and make the exponents positive. That's the shortcut there. Okay, so that's the negative exponent. Let's go to the next one. Oh, this is the last one, the 0 power, but x cannot be equal to 0, okay? So meaning if you have, let's say, number 1, um, um, 3 raised to 0, that's 1. Y raised to 0, that's 1. X raised to 0, I don't need to write it here to include that here because it's the law already. X raised to 0 is equal to 1. But let's see, we have an expression, 2x plus 5 raised to 0, that's 1. And let's see another one, z raised to 0, that's 1. 1/2 raised to 0, that's 1. So there you go. Those are the laws of exponent. Thank you for watching. Please subscribe to my videos, to my channel rather.